All right, this lesson is systems, the elimination method. So in the elimination method, what we want is for the equations to be lined up in standard form. The x's are lined up, the y's are lined up, and then on the other side of the equation, the constants are lined up. And we want that because sometimes we can kill either the x or the y just by using opposites. So since this is equal and that's equal, we can actually add these equations together. So if I take 7x and I add negative 7x, it gets to 0, so I kill these. They're gone. They're gone. Okay? And then we add everything that's left. So 4y and 2y we add together, we get 6y. 29 and 25 we add together to get 54. And so this is very quickly set up where we can now solve for y. What would I need to do? Divide by 6. Good. So divide both sides by 6. And now I know that y is 9. So remember, our solutions are the point where the two lines would cross. So since that's y, that's the second coordinate for my answer. And so I need to find x. This is where the drawback comes for this method. We're going to take 9 and put it in for y in one of the original equations, but we do have to solve for x. So it doesn't matter which equation we use. Let's just use the top one. So we had 7x plus 4y. So we're going to take the y out because we know that y is 9. And then equals 29. And then we'll just solve to figure out what the x was. So what's 4 times 9? 36. Very good, guys. So 7x plus 36 equals 29. And so that's a two-step equation. How do I go about solving that?
Subtract 36.
Good. Subtract 36. So that gets rid of the plus 36. So now I have 7x equals negative 7. And then we can get x by itself by dividing by 7. That cancels this out. We'll get x equals negative 1. So that's the other part of my answer. So my answer is negative 1, 9. That's the point where the two lines cross. So in the beginning of this, it can be a little bit easier, and then this part's sometimes a little bit tougher. This is the way that the equations are going to come out for a lot of our story problems. So we may not want to rearrange and put things in slope-intercept form or solve for x and y. Sometimes this just works out. Okay, so let's take a look at number 2. So what we have to have is either the x's or the y's be opposites so we can eliminate them. So my x's are not opposites. My y's are exactly the same. And then over here I just have some numbers. So when they're the same, we could easily make that into opposites by changing the signs. So what we're going to do is take the second equation and we're going to take the whole thing times negative 1 and rewrite it. So what that's going to do is it's going to change all of our signs. Negative 1 times negative 7 makes positive 7x. Negative 1 times negative 3 will make this positive 3y. And then negative 1 times 29 makes it negative 29. Sorry, my date's kind of in the way up there. Okay, so the first equation is exactly the same, and I like to just line those up above each other so I can see what's happening. And I'm just going to erase that date that was kind of in the way, sorry. Alright, so now I have minus 3x and plus 3x, and I can kill them. So now we have eliminated the y's. They are gone. And we can just add everything else. So negative 3x and 7x, when we add those together, we get what? Good, 4x. And 21 minus 29 would give me negative 8. Sorry, it took my brain a second to come up with that. And then we just solve for x. So divide by 4, and x is negative 2. So on my final answer, the x always comes first. So that's the first part of my answer. That's the x coordinate. And then we have to find the y coordinate. So we can put -2 in for x in either of these equations. And actually we could put it into the equation we changed too if we're really confident that we didn't mess anything up. So do you guys have a preference on which equation?
I did the first one.
Did the first one? Okay, so if I take that first equation, -3x, it would be -3 times -2 minus 3y equals 21. So we just rewrote this first equation, but we put the -2 in where the x would be. So -3 times -2 makes that +6 minus 3y equals 21. Okay, so how do we solve that? What do we need to do? Trying to get y by itself. The 3's attached. -6. Good job. So subtract 6 from both sides. Get -3y equals 15. And you're right, divide by -3. So we get y equals -5. So my answer would be -2, -5. And if you want to check your answers, remember you can put this in for x and y on both of those original equations and make sure that they add up to 21 and 29, which we talked about in the very first lesson. I should box my answer here. I'm going to draw a little line to separate these from the next set. Okay, are you guys ready for 3? Not quite? Yeah? Okay, so let's go down to number 3. Now, if I look at number 3, the x's are not opposites, the y's are not opposites, and there's nothing that's the same that I can easily change to opposites. But we can multiply either equation by whatever number we want. So let's just say, for argument's sake, we want to kill the x's. We have 6x up here, we have 2x down there. We want to turn this 2x into a -6x so I can cancel it with this 6x. What would I have to take -2 times to get -6? -3. So we're going to take that and multiply that by the whole equation. Draw a little arrow here. So -3 times 2 is -6x. -3 times 9 makes that -27y. -3 times 11 is -33. And then the top equation I'm not going to change because now I have made this equal. The one place people make mistakes is they'll do like this number and maybe they'll get this number, but they'll forget to multiply it by the 11. The only way this little trick works is if you multiply both sides of the equation. Everything has to get multiplied. Otherwise, you would be changing what the equations actually are. So let's kill the x's. Goodbye, x's. There they go. And then we can add up the y's. So 4 and -27 add up to -23. So -23y. 10 and -33 add up to -23. So when we solve for y by dividing by -23, we get y equals 1. So on my final answer, when we do our coordinates, that's the y coordinate, which is the second one. And then we'll have to go back in and find x. So we can use either of these equations. Which one do you want to put the 1 into? The first one? Okay, we can just do that. So we have 6x plus 4, and when we get to the y, we're going to put in 1, because we just found out y is 1, and then equals 10. So 4 times 1 is pretty easy, so that'll just be 4. So 6x plus 4 equals 10. And then we solve to figure out what the x is. So now what?
-4.
Good job, -4. So we have 6x equals 6. And then what do we do to solve for x?
Divide by 6.
Divide by 6. Good job. So then x equals 1, and that will be the x coordinate for our answer. So we end up with 1, 1. Okay, ready for 4? Just going to cruise through these. There's little details that show up with different problems. Let's say on the next one, I want to eliminate the y's. You can actually do either one. It doesn't matter. But let's say I want to get rid of the y. So I have 4y and I have negative y. What could I take negative y times to make it negative 4? 4. So what we're trying to do is find something we can multiply one of them by to create opposites. So if I multiply this, 4 times negative 8x is negative 32x. 4 times negative y is minus 4y, which is what I wanted. And then 4 times 0 is just 0. The top equation, I'm just going to line up. I didn't change anything on the top equation. And so I will know if I did this right if I end up with opposites and I can kill something. So 4y and negative 4y are opposites. Kill, kill. There it goes. All right, so that's gone. And basically, this is negative 1x and negative 32x. If you want to put a 1 right there, you can. And then that'll make it negative 33x equals 0, because 0 plus 0 is 0. And it always confuses people when they get a 0, but it's okay. Because if I take 0 and we divide by the negative 33, it just comes out 0, which is totally an okay coordinate to have. Just means that this one happens to be on the y-axis. It's a 0-something point. All right, so we're going to take 0, and we're going to put it back into one of our equations. It doesn't matter. Let's just do the first one. So 0, so I'm going to have negative 0. That's exciting. Plus 4y equals 0, because I put the 0 in for the x. So that 0 goes away. So I just have 4y equals 0. Divide by 4, divide by 4. Guess what? Y equals 0 too. So the answer is the origin. 0, 0. So don't freak out if you get zeros. It's okay. Sometimes they just show up. Okay. Are we ready?
Yeah.
You guys are going to have to help me make some decisions. Are you ready?
Yay.
Big decisions.
Big decisions?
Big decisions. Not really. Okay, so on number 5, I need you to decide, do you want to kill the x's or the y's?
Kill the x, it's easier.
Kill the x's? Okay. So if I'm going to kill the x's, I have negative 20x and I have 10x. So what would I need to do?
Times the bottom one by 2.
Multiply the bottom one by 2. Awesome. And so if we do that, we get 20x plus 2y equals negative 46. And then the top equation we can just leave as is. I just recopy it so I have it all nice and lined up. And we can kill those x's. They're gone. There they are. They are eliminated. That's why they call it the elimination method. So then we have 9y and 2y. We can add those together. It's 11y. 13 and negative 46 come out negative 33.
Yes.
And then we just divide by 11. Get y equals negative 3. So that will be the y coordinate on my answer, because the y's come second. And then, how do I find x? What are we going to do?
We're going to plug in the y.
So put in negative 3 for y. Does it matter which equation?
No.
Nah. I'm going to use the second equation this time just because I feel like it. So 10x plus negative 3 equals negative 23. And if you want, instead of plus negative 3, you can just change that to a minus 3. Makes it look a little bit simpler. And then we just solve for x. So what would I do first?
You're going to add 3.
Add 3. So that gets rid of this. We get 10x equals negative 20.
Yes.
Divide by 10.
Yes.
Divide by 10.
Yes.
X equals negative 2, so that becomes my x coordinate, and there's my answer.
Yes.
Yes. I'm so glad you agree with me. Okay. So here's where it's going to get slightly more interesting. On number 6, do we want to kill the x's or the y's?
Kill the y.
Let's kill the y's this time.
Yeah, get out.
Now, I can't just take 7 times something to get 5 or 5 times something to get 7, not if we're working with whole numbers. So what we're going to do is use a common multiple So 7 times 5 is 35. So we're going to convert both of them. We're going to take the top equation times 5 and the bottom equation times 7. And that should give me negative 35y on the top and positive 35y on the bottom, and then we can cancel. So sometimes you have to multiply them both. As long as you multiply one equation through by the same number and the other equation by the same number, you're good. So on the top, if we distribute the 5, we get 20x minus 35y equals 95. And then the bottom equation, we're taking everything times 7. So 7 times 7 is 49x. 7 times 5 is 35y. And 7 times 16 is 112. So it looks like, if we did all of our math right, that we now have opposites for the y's that we can cancel out. And then after this, everything's just the same as what we've been doing. So we've got to add the 20 and the 49 together. So 69x equals 207. Divide by 69, divide by 69. We get x equals 3. So we know on the final answer that our x coordinate, the first number, is 3. So another mistake people sometimes make is they switch the x and the y. So make sure the x it goes first and the y goes second, regardless of what order you're solving in. Okay, which equation do you want to use to find y?
Top one.
Top one, sounds good. So we'll have 4 times 3, because we're putting 3 in for x, minus 7y equals 19. So 4 times 3 is 12.
Yes.
Minus 7y equals 19. Sometimes people get confused when the variable's here and that constant's there. What are we going to do now?
You're gonna subtract 12.
Subtract 12. Good job. So subtract 12. JC's going to get something out of this. She's earning brownie points today. So negative 7y equals 7.
Yes.
And then we can divide by negative 7. And we end up with y equals negative 1. I don't know why I wrote really big and then I wrote really small, but it's okay. So we got 3, negative 1 as our answer. Okay, so number 7 and number 8, if you're starting to get bored, are a little different. Hold on to your hats. Here we go. They are special cases, which are kind of a pain, but actually they're going to be less work than the others because, well, you'll see. So on the beginning, let's say we want to kill the x's. I have negative 14x and 7x. What could I do to make opposites with the x's?
Times the bottom by 2.
Multiply the bottom equation by 2. Good job. So this equation becomes 14x minus 14y equals 14. And the top equation is negative 14x plus 14y equals negative 11. We didn't change the top. So I set this up to kill the x's, but look what happened.
Kill them both.
I'm going to kill the y's too when I add them together. So on this side, there's nothing left. When there's nothing left, you write a 0. Over here, I have negative 11 plus 14, which adds up to 3. Most of the time, 0 is not actually equal to 3.
Yeah, you're not right.
So let's put a not equal sign through that equal sign. And when this happens and you get something that is not true, that means there are no solutions. Or you could write the little empty set or null set, it has different names, symbol that just means no. Doesn't work. Okay? Yeah, so what that means is they have the same slope, which is why these all canceled out. And they're parallel lines, so they will not cross at any point, anywhere, anytime. And you could rearrange the equations and graph them if you wanted to, just to check and make sure. But if they come out not equal like that, it means no solutions. And this can happen with the substitution method too. We just didn't go into it that far with substitution method. Okay, so let's take a look at 8. So let's say on this one, I don't know, let's say we want to eliminate the x's. The numbers here are a little trickier, they're bigger. And so you'd have to find something that you can turn both of them into. So lucky for you, I worked this out ahead of time. We're going to change the 16 and the 6 into 48s. So I happen to know that 16 times 3 is 48. And I happen to know that 8 times 6 is 48. So we're going to take the whole top equation times 3 and the whole bottom equation times 8. So I worked with the smaller numbers. You could also work with the 40 and negative 15. Doesn't matter as long as you kill something. So 3 times 40 is 120x. 3 times 16 is 48. That's why I picked it. And then 3 times 0 is just 0. 8 times negative 15 is negative 120. 8 times 6, this is going to be minus 48y, and then 8 times 0 is 0. And so I was aiming to kill the y's, but I accidentally killed the x's too. I got 0, but this side also came out 0. And it won't always be 0 and 0. You could have opposites like negative 5 and positive 5, or negative 8 and positive 8. But if it comes out 0 equals 0 and everything's all equal and just basically everything got eliminated from the entire equation, that means these are actually the same line, that they were just written in different forms. It was identical, that's why everything canceled, and that's when you have infinite solutions. And so any point that was on that particular line would be a solution to both of these equations because they're the same equation. Okay, that is it.